Alright, next example is we're going to do the whole thing. So we're going to set it up, find the feasible region, find the corner points, and test for our optimum value. And I don't know why it says example 4, it really should be example 3. But this is just basically a complete example, application, setting it up, and solving. Alright, so we've got Kim. She makes 2 different types of quilts. She makes a queen size and a twin size. Each quilt is embroidered and then quilted together. Right? Embroider is sort of all the little detail work. And then, so they're the patches, right? You have patches, and so that's the embroidering part. And then you put the quilt together. Right? You sew all the patches to make the quilt. And we want to figure out how many quilts of each side, because twins are smaller, queens are larger, does she need to make in order to maximize her weekly profit. So we want to optimize, and we want to find a maximum profit. Given her limitation, given her constraints, right? She's limited on time, right? That's what the limiting stuff is going to be this week. So she's got an assistant. So her and her assistant do. Her assistant does the embroidery. She does the quilting. All right. So her assistant does the embroidering and is available at most 18 hours a week. So that's the important part. 18-hour a week for embroidering. Kim does the quilting, and she's available at most 16 hours a week, and those are our limiting values. Every twin size requires 1 hour to embroider, 4 hours to quilt, and the queen requires more, right? 2 hours to embroider because it's bigger, and 5 hours to quilt because it's bigger. This is going to be where we're going to get our constraints. Right? What we're limited by is time. So we're going to have 2 inequalities, one involving the amount of time she has embroidering, one involving the amount of time she has to quilt. And then this last one is the profit. That's going to come from the profit. So the last equation is Kim makes a profit of $100 for each twin and $150 for each queen, right? She sells the queens for a little more because they take a little bit longer to do. And so that's going to be the optimum values. And so there's all of my information. I kind of tried to set it up nice and neat in this case so you can see all the parts. And so now is the putting it together and then solving. Alright, so the first step, set up the problem. Define your variables. Well, twins and queens are what we want to find, so I'm going to let x be the number of twins, and y is going to be the number of queens. Queen size, twin quilts. Alright, so there's there's the first part, define your variables, write the system of constraints, give the objective function, don't forget your implied inequality. So it's up to you how you want to start. I'm actually going to start with the objective, which is to maximize profit, just because it's the easiest part. And so I'll start with that. Alright, so I'm going to let P be my profit. And so it's just how much do they make from each one. So $100 for each twin, so $100 for each of the X1s, so 100X. And $150 for each queen, so $150 for each of the Ys, alright? And so there's and I kind of set that one to the side, because I don't come back to do this until I've found my feasible region and my corner points. Alright, so that was sort of the easier one to find, and so I find that kind of first and then set it to the side. I'll come back to it when I get to my table. Alright, now the hard part is find the system of inequalities, and don't forget the implied inequalities. So I don't forget the implied inequalities. I typically write them down first. So the implied inequalities, we're talking about quilts. I can't have negative quilts. And typically on applications, it's always going to be the positive numbers. And so X has got to be positive. I got to have positive twins, and Y has got to be positive. When I go to graph this, it's only in the positive part of my graph. It's only in the first quadrant. Those are important. It's important to only pick positive values, so it's important to include those. Alright, those are my implied inequalities. And now the ones coming from her embroidering and her quilting. Alright, so first one comes from the embroidering. So she has at most, I'm going to kind of write this down here, over to the side, at most 18 hours to embroider. At most means that's it. She can't spend more than 18 hours, but if she's fast and efficient, she could spend less than it. And so that's going to be less than or equal to 18. So my first inequality is going to be less than or equal to 18. Right, 18 is the maximum. Or I could be less than 18, but I can't go over 18. So my equation on this side is going to be my equation. Creating my quilts has to be less than 18 hours or up to 18 hours, equal to 18 hours. All right. And so this is the embroider part. And so so I usually write my variables down, right? Creating my equation involves my x and my y values. And so I'm doing the embroider part. I'm embroidering. How much does my embroidering take on my queen size? Not my queen size. My twin size, right? X represents my twin size. Well, it's 1 hour, right? And so for each one of these, it takes 1 hour. And so I'm going to write 1 times x so we understand. You could leave the 1 off, but that's technically what it is, 1x. And then I do the same thing for the y. Y represents my queens. Well, how many hours do my queens take to embroider, right? I'm looking at the embroidering. Well, 2 hours, right? So every one of those requires 2 hours. For each hour I spend on twins, and for every 2 hours I spend on queens, I can only spend up to, but less than, 18 hours total. And so there's my first equation. All right, now my second equation is going to involve the quilting, right? So for quilting, she has at most 60 hours per week. So I'm going to write a similar statement over here. At most, 60 hours for quilting. Right? Putting it together, that's what it is. At most, again, means that's the maximum. So I can be up to 60, but less than 60. And so this is going to be another less than or equal to my maximum, which is 60. I can quilt up to 60 hours, or if I'm really efficient, I could go less than that, but I don't have any time more than that. 60 is my limit. I can't go over 60. And so then we do a similar thing. I know I have got to quilt my twins, and I've got to quilt my queens, and they take so much time. And so we'll start with the twin first, the x value. So remember, the x value is the twin. For quilting, putting it together, it takes 4 hours for a twin, so 4x. And the queen takes how long to quilt? Takes 5 hours, so 5y. Right? And there is my system. Don't forget, these are also part of my system. But there is my system. Alright, so I want to optimize profit selling queens and twins. Quilts, queen size and twin size. I can only, again, I'm limited by my hour. She's limited by how many hours available. Alright, so there's my limitations and the fact that I only have positive quilts. Find my feasible region, plug it in my profit equation. Find my feasible region, my corner points, because those are what's going to optimize my profit. Alright, so my next step is once I've got it set up, we'll get to work. Alright, so I'm going to start here, and I'm going to kind of do my work, and then my graphs on my next, down here. So I'm going to do my work kind of up here to get to my graph, because these are my equations. Alright, so my first line was x plus 2y equals 18. So again, I use my intercepts because a lot of times my intercepts are going to end up being my corner point. So first one was x is 0. So 2y equals 18. So y equals 9. So 0, 9 is my first point. Alright, and then, oops, I put 2 zeros in the same spot. 0 for the y. Y equals 0, x equals, well, 0 is out, x equals 18. Alright, so 18, 0. And then I'll test it after I graph it. So I'm going to go down and graph it. So 9, 0, and 18, 0. Or 0, 9, and 18, 0. So 0, 9 puts me here. 18, 0 puts me there. Alright, now I've got this is the one that I have trouble graphing. Alright. I didn't do that much better. Right, so there is my x plus 2y equals 18. So x plus 2y equals 18. And so I'm going to use 0, 0 as a test point. All right, 0, 0 is going to be my test point. All right, test 0, 0. And so 0 less than or equal to 18 is true. And so I shade above. So I'm just going to write my arrows. I'm going to shade above that blue line. All right, now my red line. 2. 4x plus 5y equals 60. Same thing. I'm going to find my intercepts. Alright, so x equals 0, 5y equals 60, not 160. 60, y equals 12. So 0, 12, and then same thing over here, y equals 0, that's y. 4x equals 60, x equals 15. Alright, so 0, 12, and 15, 0. So you gotta make sure to do those in the right. 0, 12, so 0, 12 puts me up here, and 15, 0 puts me here. Alright, so both of these are going to be my hard cases to draw. And yes, horribly done. I'm trying to draw it because I know they're going to meet here, so. Oh, what I wouldn't give for a straight edge. Alright, there's my horrifically drawn red line, which represents 4x plus 5y equals 60. And same thing, 0, 0 is going to be the true side, because it's going to be 0 less than or equal to 60. And so that's true, and so I'm going to shade above both of these. And then don't forget, there's also the implied inequality, so remember these. And that means I'm always going to be in the... So when I gave you the graph, I kind of already knew that those were going to be my implied inequalities, right? The x and y axes are an edge. And I want to stay above the x and y axes. And that was the y equals 0. This is the x equals 0, and I want to stay on the positive side. And so when I go to shade this in, I keep it in mind. I'm above both my lines. I'm above the red line and above the blue line. So all of this is false. None of that's a part of my solution. And then also no negative. So none of these are part of my solution. Make sure I block out all of the areas I don't want. And so again, it's sort of a triangular shape. It's not really, because again, there's this kink in it. But it's kind of a triangular shape. There's my feasible region. And then my corner points. I'm going to list those. And so I've got a corner point here at the origin. And for these cases, a lot of times, not always, but there are a lot of them where one of the corner points is the origin. Then there's one up here, which is B. There's this wonky one here, which I tried to get when I drew horribly. C. And then there's this one at my intercept there at D. Alright, so my corner points are A, B, C, D. Right. A is the 0, 0, the origin. Goes through x equals 0, y equals 0 line. That one I don't need to check. Alright, then the corner points B also was one that I used, so I don't have to check it. That's the point 0, 9 that I used. 0, 9 went through my x-axis, so the x equals 0, and the line, the blue line, which was x plus 2y equals 18, and it checks. Again, I don't need to check it because it's one I use. Same thing for C. C is, not C, D. I'm going to do D before C because D is the other easy one. It's here, it's the corner point I used, which was 15, 0. And that goes through y equals 0. And the red line, 4x plus 5y equals 60. Alright, C is the only one that I have to make sure I check it. And I knew the value it was coming out to be, so I tried to sketch it that way, but our sketches aren't always perfect, so this is the one we actually always need to check, the one where they sort of intersect. I did try to make it come out where it was supposed to, which is at 10.4, and it is at 10.4. 10.4. It goes through the lines. x plus 2y equals 18, and the 4x plus 5y equals 60. If your sketch doesn't come out nice, if you're a little off, what you either have to do is you have to graph those and find where they intersect, or solve the system. And if you solve the system, meaning solve this matrix system, you should get x equals 10, y equals 4, and if you're in doubt, check it, plug them in, and it does check out. So these do check, and you should always make sure those check. Alright, so there are my 4 corner points. Alright, my 4 corner points that I'm then going to look for my objective. And so my objective function was 100 times x plus 150 times y. And I like to write it down here because these are my possible objectives and which one's going to give me out my biggest profit. So 0, 0, it is the minimum, right? If I don't make any, I don't make any profit. And so in that case, profit comes out 0. Right, then we plug in 0, 9. So 0, 9, 150 times 9 is 1350. And then 10 for x, 4 for y. Again, I'm plugging them in this equation, so it comes out 1600. And then the last one, 15. And that's my biggest, right? This would be the smallest. It gives me both, smallest and biggest. I want maximum. All right, so now the answer. Kim needs to make, in order to maximize her profit. All right, so the maximum profit will be 1600. When she makes, well, this is her objective, x is 10. So remember, 10 represents the twins. So when she makes 10 twins and 4 queens. Alright, so if she produces 10 twin-size quilts, 4 queen-size quilts, she'll make a best possible profit of $1,600. That's the best she can do. Based on her limited amount of time, she can make 14 blankets, 10 of them twins, 14 of them quilts, and she'll get a profit of $1,600 if she does that. All right, example 5. So this is kind of like the last example. All I did was change the profit. So I'm not going to find a new feasible region. Suppose Kim, the same quilting situation, same limited amount of time, and so the feasible region's exactly the same. All right, exactly the same feasible region, same corner points. But what she's going to do is she's going to change her price. All right, she wants to make a little more money, and queens are just a lot of work. All right, and so she's going to up the price on the queen size quilts. She's going to leave the price of the twins the same. And so her profit changes. The queen size quilt is now worth $200 a piece. Her twins is still going to stay 100, and so she's got the new objective function where instead of 100, remember this was 150 in my last example, instead of 150 times y, it's now 200. She raised it by $50. And so the table is exactly the same as what we had earlier, except I think it might be in a slightly different order. C and D are in different order. When I wrote it down here. But the points are all the same. 0, 0, 0, 9, 15, 0, and 10, 4. What's new is what we're going to plug them into. So same thing, we're going to plug them in here. So 0 is still going to give me out 0. But 9, now I'm going to plug it in here. That's going to give me out 1800. Plug in. So this one's different than what I did before, 15, 0 for that one. It's going to come out 1500. And the 10, 4 comes out 1800 as well. And so I wanted to do this example because this can happen. There are one maximum profit. The biggest possible profit she can get is 1800. It's the biggest. But she now has 2 ways to get that. There's 2 different things she can do in order to maximize her profit. So she's got 2 solutions. Alright, so the first part, this part's the same, right? She has one profit that she can maximize. Her maximum profit is 1800. Alright, that's the largest profit she gets. She can't make more than 1800. But now she has 2 options. Alright, she's got 2 options. Either she can go with option 1, which would be the B coordinate. She makes 0 twins and 9 queens. Since she raised the queen price, all she has to do is make 9 queen size, and she's got her maximum profit. Or she's got a second option. She can make 10 twins and 4 queens. Now they'll give her the same profit. So 9 queens and no twins will give her the same profit as 10 twins and 4 queens. That profit that they both will generate will be $1,800. So she has to decide which one is the least amount of work. What also might come into play is the demand. Does she have a higher demand for the queens? If that's the case, she wants to go with option 1. But if there's a higher demand for twins, she might want to go with option 2. She kind of has to know her market a little bit. Right? So if demand for queens is the higher case, option 1 is the way you want to go. If the demand for twins is the higher one, though, option 2 is the way you want to go. All right, both of them will give her her optimum profit, and that can happen. Right, so the biggest profit can occur at 2 of the corner points, or the minimums can also. This will also happen with minimums. You get 2 minimum values occurring at 2 different. So basically, you get a profit happening, the same profit happening, with 2 different variable cases. All right, and again, that can happen. So that's my sort of note. This last example is the possible where you can have optimal solution that occurs at more than one corner point, more than one option, and then you have to decide which option is the best way to go. Alright, try it on your own. I just gave you an example of, I already found the corner, but I would encourage you to see if you can't get to these corner points on your own. See if you can't draw this out and find the corner points. So these are the corner points that you should get if you do draw it out. You should get the corner points 0, 20, 0, 10, 12, 12, and 16, 6. This is just asking you to find the objective, but if you want to practice, I'd say practice, see if you can't find the feasible region and find these corner points on your own. Alright, so that's for you to do on your own. We'll stop there.